Okay, Matrix, we're sketching cubics. Let's look at the points of inflection again. We got the first derivative, the second derivative. I must be honest with you, second derivative might seem a bit strange to you. Okay, but don't panic, there is an easier way to do it. And you get x equals naught, the points of inflection at naught, -4. But there is a brilliant way of doing this. Another way is if you add up the x coordinates, remember these were the stationary points. If you add up the x's of the turning points, look at this, you add them up and divide by 2, you get naught, which is precisely what you got previously. Do you see how brilliant that is? So if you've got your stationary points, the x values, you add them up and divide by 2, you get the x value of the point of inflection. It's really, really cool. Okay, so now let's summarize all this information. There we've got our little graph. Remember, it was that shape there. And what do we know? That's our x-intercepts, -1 and 2. What do we know? There's the y-intercept. Okay, if you've got that. We also have the stationary points. Now remember, there's one here, this turning point. Let's just draw something here quickly. There's a point there and a point there. Those are the stationary points. Okay, and the graph is, and you can see it's actually increasing here. It increases. And here it's decreasing, goes down, and then it increases again, and there the derivative is naught. What else do we know? We also have a point of inflection, which is at this point there. Interestingly, it's 0.4. It's coinciding with the y-intercept. It doesn't always happen like that, as you'll see in the next example. Okay, now have a look here. There we go. So we've got our little cubic graph. It's a nice shape there. Don't forget the arrows. And also, very important with this, don't forget to put the x and the y. Okay, and there you've got the main features of that graph, which is rather pretty cool. I don't know if you're enjoying this as much as me. They are gift things. I mean, 15 marks for a cubic graph out of 150. I think it's pretty cool. Should we get a little bit more technical? Okay, I want you to write fast with me. We've got to get through this. We've got 2 lessons, this lesson and the next one. Now let's check. Here's one where it's sad, -x³. And they want us to calculate the x-intercepts of the graph. Remember, if it's sad, it's going to look like that, with the 2 turning points there. Okay, so it goes down, decreases, turns, increases. There you go. And remember, your points of inflection would be somewhere there. Okay, so little points where it changes from being happy to sad. Okay, how do we get the x-intercepts? Well, we let y be naught. Remember, fx is y, so we let it equal naught. Now, here's another smiley face, another cubic equation. What I could do, have a look at this, is I could, of course, bring everything to the left to make my life a little bit easier. Not necessary to do that. Remember, your original is the negative shape. Now, let's see. We're going to try and factorize this cubic. Now, I'm going to do it with my method. You can do long division if you like. Let's see what we can get out of this. Okay, great. Now, there's the one I've restructured. So I'm going to try the factors of 12. There's a whole lot of them. 1, 2, 3, 4, 6, and 12. Numbers that go into 12. And shall we get the one that works straight away? Okay, let me give it to you straight away. Watch this. Okay, I'm going to try x equals 2. And guess what? It comes to naught. So x equals 2. 2 cubed minus 2 to the 4 minus 8 times 2 plus 12. And it gives you 8 minus 4 minus 16 plus 12, which guess what is naught? And that's what we want. We want it to equal naught, because if x equals 2 is a solution, if you substitute it in, it must give you the right-hand side of the equation, which is naught. So this is wonderful. That worked very well. Maybe there would be others that work too, but now we know that x equals 2 is a solution, and I am seriously in love. Okay, let's make it nice and hot. There we go. Oh, aren't you in love with that? You're my zero. You're my hero. Okay, there we go. It works for me. Okay, now I've got that. Now what do we do? Now I'm going to use the smiley face. You can use long division if you like. Let's test this. Okay, so x equals 2. Okay, let's see. What do we have? Okay, so we've got x equals 2's solution, so we bring it across. Now with the smiley face method, let me go through this method a little bit slowly now. Okay, now listen to me. Watch what I'm saying. Okay, if you use long division, take this equation, do it the long division way, you'll get exactly the same as me. I'm using one specific method. Okay, now watch this. I'm going to put into here, so I've got my solution, and I'm going to put in x minus 2. There we go. Right, I've got that. And then what do I know? Okay, I'm going to then say, okay, from the cubic there, I'm going to take x cubed and I'm going to divide it by that x, which gives me x squared. And x squared says I'm going to be in the first place there. Right, then what I then do? Okay, I take the 12, bring him down, and I divide by the 2, the minus 2 there, giving me negative 6. And where does negative 6 go? It goes to the end there. And then I put a little missing term in there. Okay, now once I've got that, I'm going to solve for m. Now, what I want you to do is I want you to try and get m either using your long division method or try and connect the x squareds, guys. So write this down, connect the x squareds, get me the value of m, and let's proceed to factorize and get the x-intercepts. So give it a best shot. We'll return after the ad break on Matrics Uploaded. Stay with us.